In this video, we're going to be exploring how to graph quadratic relations. You'll need to have already watched the Investigating Transformations video so that you can better understand vertex form and what each of the variables represents. This is vertex form at the top right here. Let's just jump right into our learning goals. All right. By the end of this video, you should be able to sketch graphs, write the equation for a graph, and also use those skills to solve word problems. All right, let's jump in with learning goal number 1. I'm going to write an equation, and what we're going to do is describe the properties of the graph of that equation. So y equals 2x minus 4 squared minus 3. Now what we're going to do is compare this to vertex form. We're going to look at each of these numbers and figure out what they mean. Now it's important to remember what A does, what H does, and what K does to the graph, right? A is the direction of opening, but it also determines if it's a stretch or compression. H is going to tell us the horizontal translation. And K is going to tell us the vertical translation. Okay, so we'll leave this off to the side over here. Awesome. Okay, so if I look at this equation, I see that where my A value is, we can label these. This is A, this is H, and this is K. Where my A value is, I see that I have the number 2. That means my graph is going to be stretched by a factor of 2. And we know that because it's following the rule that A is greater than 1. That's our rule over here. You need to have your rules out for this video. I think it'd be really helpful for you. So take that out from the Investigating Transformations video. Okay, next we have our H value, which is a -4 in the equation, when in reality that means it's +4. And if it's positive, that means I'm having a horizontal translation to the right. So it's going to be stretched by a factor of 2. Translated to the right by a factor of 4, right? And that's because H is a positive number. That was our rule from that. Okay, I have some trouble here. I gotta make some more space. Move it over here. Okay. My K value is -3, and that determines the vertical translation, so whether it's going to move up or down. Because K is negative, the parabola is going to translated, I should say, downward by a factor of 3, right? and that's because k is a negative number. Those are the rules that I'm writing in there. Right? So this one looks like this. If h is greater than 0, so that means a positive number. And then for k, this one is k is less than 0, then it's going to go downward. You can also remember it as, if it was a positive, it's moving to the right. If it's a negative, it's moving left. If it's a positive, it moves up. If it's a negative, it moves down. You can do that as well. There's another thing that we can tell with A, which is the direction of opening. So if A is positive, we know it's going to open upward. All right, so all of this information here is going to help us sketch this parabola. Now there's something in this video that we haven't learned yet, and it's about H and K. H and K actually represent the vertex of the parabola. So let me grab a different color here. Let's use green. So we've got 4 and 3, negative 3 I should say. This is our vertex. So our vertex represents x and y. Now you have to remember the x value here is 4, positive 4, right? And then the y value is negative 3. So from all of this, we can now graph our parabola. Let me see if I can make it fit on this page. Let me grab a Cartesian plane. Oh, wrong layer. There we go. If I make this a little bit smaller, it's a sketch, so it doesn't have to be right on the money, but I just want it to be big enough that you can see it. Okay, I think that should work. All right. Just had to make that a little bit bigger. Okay, so what I'm going to do is I'm going to sketch the parent function into the graph so you can see. Ooh. Where we're starting, okay? And I'm going to choose a different color. So I know that this parabola is going to move to the right by 4 and down by 3. So I can actually do that. I could go right 4, 1, 2, 3, 4, and I can go down 3, 1, 2, 3. And I could double check that that's correct because I see in my vertex is 4, negative 3, right? Which we saw from earlier. And then from here, I know it's going to open upward because of my A value. And it's going to be stretched by a factor of 2, which means it's like grabbing an elastic band, right, and pulling it upward. So I'm going to draw it a little more stretched than the parent function. It's not going to be exact because we're just sketching. So it's going to look a little something like this. Perfect. Now there's one more thing that we can tell from all this information, which is the axis of symmetry, because we know that parabolas are symmetrical. So my axis of symmetry is 4. How do I know that it's 4? Because my x value is 4, and that is what's right in the middle here, right? So if you ever get a question that's asking about the axis of symmetry, you know it's your x value. Whenever you draw a parabola, you want to label it with its equation. So this is y equals 2x minus 4 squared minus 3, right? Even if we labeled our parent function would be y equals x squared. Just so you can see how the parabola is evolving. Now there's a couple more things that you need to know here, and that's determining about x and y and what kind of number it can be. So x can be any real number here. I might open up Desmos to show you this. Okay? X can be any real number. So if I go on any point on this parabola, I can go here, I can go over here, I can go over here. It's going to continue to go up and stretch and stretch and stretch and stretch and stretch. X can be any real number. But what's important to note is y. Y, our y value, it can also be any real number, but there is a limitation. Whoops. Any real number. Okay, but if I look at my y value, it only goes to a certain point down here. Can my y value be negative 6? Does this point go down to negative 6? It doesn't. So the y value is restricted by our minimum point here. It can be any real number that is greater than or equal to negative 3. Okay, and a way that we can write that is, let me just make some space over here. So we can write that y has to be greater than or equal to, getting kind of cut off here, let me try to make it fit, y equals, there we go, greater than or equal to negative 3, right? Because it can't be just any real number in this situation. So it's important to be able to look at your parabola and tell what x can be and what y can be as well. Okay, let's go to our second learning goal. Okay, so for our second learning goal, we're going to learn how to write the equation for a graph. So let me try to draw a graph for you here. Okay, color. All right. Let's see. I'm going to put this here, and I'm going to label that. And I'm going to label that point. And then I'm just going to draw our parabola like that. That's not half bad. Okay, so what is the equation for this parabola? Well, let's take a look at the information that we've been given. We've been given a vertex, right? Let's just write our vertex form first, just to jog our memory. Okay, so we can input it underneath here. We've been given a vertex, so we've been given an h value and a k value. So that means I've got y equals a x. I have a positive 1 on my parabola, which means I know this has to be a negative 1. And then and my k value is how high it moved up. So I've got, oops, I need to write plus 5. So I used my vertex for this, right? Because I have 1, 5 for my x and y, which is the same as my h and k. Awesome. Let's continue to see what else this graph tells us. The graph also gives us a point. It gives us a coordinate here. This coordinate has an x and y in it. Well, let's use a different color here. X and y. Well, I also have an x and a y in vertex form, so I can substitute that in. 0 equals a. Oops, not 0. My apologies. 2. My y value 2 equals a. 0 minus 1 squared plus 5. So now I have an entirely new equation for this parabola that's going to allow me to solve for the one variable that I'm missing, which is a. I do not have a value for a. So let's rewrite this and solve it. Let's rewrite it without all the colors so we can just focus on solving. Here we go. Okay. I'm going to do my brackets first. 0 minus -1 is still -1, -1 squared. So we've got okay, 2 equals a. The reason it's a is because, oh, it's not writing. Let me get it up for you. There we go. So -1 times -1 is 1, right? So, and then 1 times a is just a. So we're just going to leave it as a plus 5. And then we're going to isolate. So if I bring a to the other side, it's going to become negative. And if I bring 2 to the other side, it's going to become negative. So then we've got negative a equals 3. And then we're going to have to get rid of that negative. So divide or multiply by -1. I'm just going to divide. So then I've got a equals -3. This is great because I know that my a has to be negative due to the fact that the parabola is opening down, and the parabola also appears stretched compared to what the parent function would look like. I can try to draw the parent function in here, which is always a little bit wider. Maybe not that wide, but right? So now we can write the equation for this graph. So the equation for this graph is y equals my a value, -3, x, my h value, -1, and my k value, +5. I'm going to just erase that for you so you can see it a little bit easier. And there you go. You've written the equation for a graph. Let's try to tackle a word problem now. At a fireworks display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. Determine an equation to model the flight path of the firework. How's that? All right, so what we're going to do first is sketch what's going on. So let me grab a graph, or Cartesian plane, I should say. Okay, this should work. All right, so I've got my height over here, right? And then I've got my distance going this way. The reason I can label these here is because the firework is going to come up and down. It's not going to go, you can imagine this as the ground, right? I know it's not going to go underground, so I'm going to be drawing everything up here. So it is launched from a height of 2 meters. So that means it starts at 0, 2. I feel like I'm going to have to do a different scale. Let me write a scale for you guys first. I'm going to go up by 10. I'm going to go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, and so on. Okay, and then my distance, I'll do the same thing. 5, 10. Make sure we put our unit. 15, 20, 25, 30, 40, and so on. Okay, now we can draw. So it starts at a height of 2 meters. Okay, maybe I'm going to get a brighter color. I'll use this one. Okay, so I know that at that point right there is 0, 2, right? Because this is my x. It hasn't moved anywhere left or right here yet, but it's moved up by 2, right? Okay, then it tells me that I've got, oh, my iPad. Okay, I thought it was a program that wasn't responding, but it was the Apple Pencil that died. Let's get back to it. Where was I? So we marked the point where the firework was launched from. So we have a coordinate. And next, what we can do is we know that it reaches a maximum height of 40 meters at a horizontal distance of 10 meters. Okay, so this is our key word here is maximum, right? Because we know that a parabola can have a minimum or a maximum. So its maximum height is 40 at a horizontal distance of 10. Horizontal distance, that means my x, also known as my h, right? And its maximum height of 40 is my y, which is also known as my k. So I have the vertex here, which I can label at 10 and 40. 10 and 40 is about here. Okay, so now I can start to sketch my parabola. Whoa. I'm going to do my best here. Try to make it look symmetrical. So that is the flight path of our firework. We can label our vertex, which is 10 and 40. Okay? If we look at our vertex form equation, where am I going to write this? I'm going to write it here. Y equals a x minus h squared plus k. Does this situation look familiar to something that we've done in this video before? Are we able to use the information in the graph and substitute it into the equation to solve for a missing variable? We are. What variable are we missing here? We're missing a. So let's go ahead and substitute. Oops, I'm not using the right color. There we go. I'm actually going to erase these. There. Lovely. So I've got y equals a x minus h squared plus k. All right, let's substitute in. We have a y value, which is 2, from our coordinate point where the firework is launched from. I don't know a. I've got an x value, which is 0, from where the firework was launched from. My h value is 10, but we know that because it's positive 10, in here I'm going to have to write it as negative. And I've got a k value, which is 40. And now I just can proceed to solve. Okay, so 2 equals a. The 0 goes away. Now we can get rid of the brackets. Negative 10 squared is equal to 100. So we're going to write this as 100a, right? And then we've got plus 40. And then I'm going to bring my 40 to the other side. So I'm going to do negative 40 plus 2 equals 100a, which is negative 38 equals 100a. So now I'm going to divide both sides by 100. Dividing both sides by 100 here to isolate. So then I have a equals negative 38 over 100. Okay? And you can also have that as a decimal, which is a equals negative 0.38. Let's make that a rectangle. There we go. So now that you know your a value, you can answer this question, which is determining an equation to model the flight path of this firework. Well, the flight path of this firework is y equals negative 0.38 x minus, I've got 10, and then I have plus 40.